Sulfur is in the sixth column. Oxygen is in the sixth column. And there's two of them. 6 times 2 is 18. Sulfur's in the middle. 2, 4, 6, 8, 10, 12, 14, 16, 18. Sulfur still needs 2. One of these oxygens is going to have to supply that 2 with a double bond. Why the one on the right? Random, which means this molecule can resonate. Calcium carbonate, metal, which means it is an ionic compound. Metals have no electrons. Nonmetals are full of electrons. This is a polyatomic ion, so we're going to have to draw it as if it was a molecule. Carbon is 4. Oxygen, 6 times 3, 18. Plus, carbonate is negative 2. 2 more, 24. So we have one of those. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, done. Carbon still not satisfied. So we're going to have to take a pair of electrons from one of the neighbors and make a double bond, which means, of course, the sucker can resonate. So that is the dot diagram for calcium carbonate. Carbon, 4. Iodine, 7 times 4 is 28, plus 4 more, 32. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Easy peasy, lemon squeezy. Silica, 4. Chlorine, 4 times 7. This one's very similar. Virtually the same thing. This time the silicon, who can also bond 4 times. "32. Hydrogen is a non-metal. Sometimes it acts like a metal. This time it's just acting like a non-metal. 1 times 2. Sulfur, 6, 8, 2, 4, 6, 8. Easy. Lithium, definitely a metal. Metal. Metals, brackets, no electrons, non-metals are full. You need 2 of them. Done. Carbon chain, 4 times 4, 16. Hydrogen, 1 times 12 is 12. 28. Carbons all in a row, always, always. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. All right, whenever you see a dash there with nothing attached to it in organic chemistry, that is an assumed H. Organic chemistry is the study of mostly carbon chains. A lot of H's involved. We don't have the time to put all those H's, so you usually just see a dash. If you see a dash, assume an H. Polyatomic ion, nitrogen, 5. Oxygen, 6 times 2 is 12. Plus, one more, 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. Done. Unfortunately, nitrogen is missing a pair. So one of these guys is going to have to double bond. Why the guy on the left? Could have been the guy on the right. Which means this sucker resonates. Carbon chain. I have 3 carbons, 4 each. It's 12. Hydrogen is 1 times 6 is 6. 18. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Carbon is not happy. So we've run out of electrons, which means we're going to have to double bond. This molecule actually does not resonate. I don't know why it's not doing that. Because we really only have, there's no choice. One of these two pairs of electrons is going to have to move over to provide a double bond. And it doesn't matter which one because it's basically the same thing. You cannot resonate because this is actually in 3 dimensions the same thing as this. Just imagine this carbon. What if this carbon had been twisted, had been moved? Just these atoms can rotate around. So these two things are the same thing. So there cannot be any resonance. Carbon 4 times 4, or rather times 1 is 4. Nitrogen is 5. Get an extra one. That's 10. 2, 4, 6, 8, 10. Can't have that. 2, 4, 6. Can't have that. 2, 4, 6, 8. All right, so both of them have 8. Brackets, charge. Of course, once again, there is no resonance here because there is no other choice. Sulfur, 6. Remember that sulfur is one of those things that can and will bond more than 4 times. Hydrogen is 1 times 6 is 6. So we have 12 electrons. 2, 4, 6, 8, 10, 12. Done. Next time we'll look at we'll review molecular shapes in order to go through that isn't octahedral. Oxygen, 6. Sulfur, 6 times 2, it's 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. Can't have that. Double bond. Which means the sucker resonates. Be is a metal, and you would think you would do it with brackets, but you have to remember all the little exceptions. Beryllium is an exception to the rule. Beryllium is a metal that can bond covalently, and it will have 4 electrons instead of the 8. That gives you a linear molecule, if you remember. Be is 2. Bromine is 7 times 2, 16, and that's where you get the 16. Boron, also an exception to the rule, is happy with just 6. So we have 24 electrons to play with. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, done. Just in way of review, let's see which one of these molecules are polar and which one are nonpolar. Beryllium, 2 sides, same thing, nonpolar. Boron, 3 sides, chlorine, 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 same thing, nonpolar. SO2, double bonds, consider them single bonds, so you have a bond to an S, a bond to an S, and then no bond. So that is not symmetrical. It's not the same thing on all 3 sides, so you have a polar molecule. 6 sides here. 1, 2, 3, 4, 5, 6. Erase that, don't want to confuse anybody. 6. 6 times 6, all 6 sides are exactly the same, so it is nonpolar. All right, central atom, long chains, these carbon chains are all nonpolar. This is an ion, so it is neither polar nor nonpolar. It is an ion. Neither, oops, I hate when that happens. Neither carbon chains are nonpolar. All right, how about this one, H2S? 4 sides, 2 pairs of hydrogens, 2 unshared pairs. That's not exactly the same, polar. Ionic, neither. SiCl4, 4 sides, all Cls, exactly the same, nonpolar. Ci4, 4 sides, all to I, nonpolar. Ionic compound, neither. SO2, sulfur has 3 sides, 3 sides. One side with an O, one side with an O, and one side unshared. That's not all the same, polar. That's it.